Okay, so we're looking at circle geometry, and it's all pretty straightforward stuff because it's all rule-based. And really, if you just kind of follow along with the definitions, you can kind of, easily make sense of it. But I am going to take you through a few examples and kind of get you oriented, and then I'll tell you a little bit later how you're going to be assessed on this. All right, so first definition, tangent to a circle. A tangent to a circle is a straight line that touches the circle at one point, and that point is called the point of tangency. At the point of tangency, the tangent of the circle is perpendicular to the radius of the circle. All right, so that's our first little bit of notation here. So we have a perpendicular relationship. All right, so whenever you're dealing with perpendiculars, the idea of a right triangle, right angles, those skills that we covered, those could come into play. All right, so that's kind of what we're looking at. Now, number one, BA is tangent to circle C at point A. Find the value of X. All right, so nice, easy problem to get started, as long as you know that a radius and a tangent, so radius and tangent are going to be perpendicular to one another, because that point of tangency is going to be connected to the center of the circle. All right, that makes it a radius. So an extension of that relationship is that the radius and a tangent are always perpendicular to one another. All right, so I know that I'm looking at a 90-degree angle here. And I know that there's 180 degrees in a triangle. So a buck 80 minus 90 minus 22. All right, so buck 80 minus 90 is 90. Minus 22 is going to be 68 degrees. All right. We get another tangent relationship. ED is tangent to circle O. Find the value of X. So same general idea. So again, we know we have a 90-degree angle. So buck 80 minus the 90. You could really just do 90 minus 38, but I want you to be ready for situations where you're not necessarily dealing with a right angle. So, it's just a, dealer's choice there. So 52 degrees is what we're looking at here. All right, so 90 minus 38. So 90 minus 30 is 60, minus another 8 is going to be 52. All right. So then here, just flat out, find the value of X. Of course, no punctuation, so I'll take that as a typo. And we're dealing with a quadrilateral here. We learned about quadrilaterals, but we also know that radii and tangents are going to be perpendicular to one another. All right, so if I want that X angle there, I'm looking at 360 degrees minus 180. All right, those are the two 90-degree angles, minus another 130. All right, so 360 minus 180 is 180. 180 minus 130 is going to be 50 degrees. All right, so even a fairly complicated looking diagram ends up not being that terrible. All right, find the value of X. All right, well, again, a 90-degree angle here. Now, a little bit of a twist on it, because now we're not dealing with angles, we're dealing with sides. But we do know that in a circle, if you have a radius, it's going to be the same as every other radius within that circle. So that's also going to be 3. All right, so this sum here is going to be equal to 10. And so now I'm looking at a Pythagorean relationship. So 3 squared plus x squared is going to be equal to 10 squared. So 9 plus x squared, hundo, subtract it off, x squared, 91. All right, 91. Oof. Well, let's see. Well, because when I take the square root, I would be looking to simplify that. Yeah, I would divide it by the usual suspects. Not divisible by 3. Definitely not divisible by 9. 4, no, it's an odd number. 5, well, 5's not one of them. 16, no way. Get to 25, 36, not happening. 49, not going to work. 64, not going to work. So it doesn't look like there is a perfect square factor of 91, so that's all we would do. We would just leave it there. All right, we're not looking for decimal answers here unless you're explicitly asked for it, like you are in the next example. A belt fits tightly around 2 circular pulleys as shown. Find the distance between the centers of the pulleys. All right, so they didn't give us that part of the diagram, but there it is. All right, so I have to find those particular values. All right, and we are going to round our answers. Now we do have some information here. All right, so that 3 centimeters there, that 3 centimeters is related to the radii. All right, so let's, there we go, label this up. So I know that this guy is going to be 3. I know that this one's going to be 3. This is 7, and that one's already labeled as 7. All right, so I need more. I need more information. We could start getting into the fact that this is a trapezoid and solve for that kind of stuff. But we do also have knowledge about right triangles. So why not, use that knowledge to our advantage? One thing that we could do is draw a little line segment right here. I meant to have my line draw tool on. Just kind of throw that in there. Because we know that this dimension and this one have to be the same. So that's going to be 3, which makes this guy, even though it's not drawn to scale, that's going to be 4. All right. We also know that this one has to be 15. And so now we have 2 sides of a right triangle. All right. So 4 squared plus 15 squared is going to be equal to, we'll call that c squared. All right. So 64, geez, where are you getting these numbers from, pal? I just, in my mind, I saw an 8. That's my story, and I'm sticking to it. 16 plus 225, well, that's going to be 241. Now, they let us off the hook when it comes to simplifying. They're just saying round it. So the square root of 241 is going to be nearest tenth, so C is going to be approximately 15.5. Any units? Oh, right in front of my face. 15.5 centimeters. All right. So that's the first part of the lesson. A couple more pages to go, but it's pretty straightforward conceptually.